Close your eyes for a moment. Picture a glass of water, simple, clear, ordinary, sitting quietly on a kitchen table, half water, half air, a perfect division, the favorite metaphor of optimists and pessimists. To some, it's half full, to others, half empty. But what if it were literally half empty? Not emotionally, not metaphorically, physically, scientifically, absolutely empty, a vacuum, no air, no sound, no atoms jittering around, just nothing. What would happen? Before we can answer, we have to understand. What is nothing? In physics, a vacuum is a space devoid of matter. No molecules, no atoms, no resistance, not even silence, because even silence requires a medium to be silent within. If we removed the air from the top half of a glass of water, we wouldn't just create space. We would create imbalance. And the universe hates imbalance. Nature despises a vacuum. It can't stand unfilled gaps. So it pushes. Hard. Atmospheric pressure, that invisible force pressing on us every second of our lives, suddenly acts unevenly. Normally it presses on the glass from all sides. But once the top half becomes a vacuum, the balance shatters. It's as if the universe screams, "Fill this nothing, now." And it does. Air molecules, like runners in an invisible race, charge toward the empty space. The fastest among them travel over 1,000 meters per second, chaos racing to restore equilibrium. If the vacuum is open to the air, it won't last a millisecond. Air rushes in, collides, compresses, vibrates. A tiny thunderclap erupts, a pressure wave that echoes through the glass and water, like a message encoded in sound and matter. But what if the vacuum is sealed? Imagine the top half of the glass is closed off from the world. No air molecules can enter. A perfect dome of glass isolates the vacuum from the atmosphere. Now the water beneath faces the impossible. Above it, absolutely nothing. And the nothing begins to pull. Except that's not quite accurate. In reality, vacuums don't pull. It's the surrounding pressure that pushes. Suction is just what we call the absence of resistance to that push. The water, no longer held in place by atmospheric pressure above, begins to evaporate, even without heat. Because boiling isn't only about temperature, it's about pressure. Lower the pressure enough and water will boil at room temperature. It will quietly begin to unravel itself, molecule by molecule, trying to fill the emptiness. It's a kind of molecular escape. One drop at a time, the water becomes vapor, but the vapor has nowhere to go. It expands freely, chaotically into a space that doesn't want to be filled. It's a ballet of particles in a theater that resists choreography. Now imagine something stranger still. What if the vacuum wasn't on top, but on the bottom? The water now floats above absolute emptiness. Above it, air. Below it, nothing. It has no foundation, no support. And so, nature acts once again. Air pressure begins to squeeze, not just the water, but the entire glass. The bottom, now unsupported by the usual cushion of air, begins to give. Then something remarkable and violent happens. A phenomenon called the water hammer effect. You may have heard it before. A sudden clunk in old pipes when you turn off a faucet. Water, you see, doesn't compress. So when it moves quickly and slams into something, the force isn't absorbed. It's delivered all at once. A sharp, unforgiving shock. In our scenario, the water, falling into the vacuum, crashes into the bottom of the glass with tremendous force. And the glass shatters. A sharp crack. Fragments fly. Water splashes. The moment is over before you realize it's begun. All because we made the glass literally half empty. Let's rewind for a moment. Back to the original scene. The glass, sitting on the table, before we imagined vacuums and shock waves, before we summoned the wrath of physics. The glass is still there, half air, half water. A metaphor, they say, a way to talk about perspective. But what if it's more than that? What if the metaphor hides something deeper? Maybe the glass isn't half full. Maybe it isn't half empty either. Maybe it's in transition. Because everything is. The molecules in the water, the air above it, the thoughts in our heads. Nothing truly stands still. The universe itself is a cycle of filling and emptying, of inhaling and exhaling, of becoming. Maybe that's what the glass is trying to tell us, that even in stillness there is movement, that even in balance there is pressure, that even in emptiness there is potential. This started with a simple question. What would happen if a glass of water were literally half empty? And it led us down a rabbit hole of vacuums, evaporation, pressure waves, structural stress, and philosophical paradox. Maybe that says more about us than about the glass, because we can't help it. We seek meaning, even in nothingness, especially in nothingness. Think now about the empty spaces in your life, the parts that feel incomplete, silent, absent. Maybe they're not broken, maybe they're necessary, because sometimes it's the space between notes that makes the music. It's the pause in a sentence that gives it power. It's the black between stars that forms the constellations. The universe doesn't fear emptiness. It builds upon it. Maybe we should too. In the end, perhaps the glass isn't about optimism or pessimism at all. Perhaps it's just reminding us that emptiness is never permanent, that pressure always finds a way in, that change is inevitable, and that even the most ordinary object can contain the extraordinary, if we dare to ask the right question. If this video sparked your curiosity, if it made you look at a glass of water, or the universe, just a little differently, consider subscribing to the channel. Leave a like, share it with someone who loves turning simple questions into wild journeys, and tell us in the comments, what do you think would happen if time stopped for 1 second? That might just be our next adventure. Until then, stay curious.